Hello everyone, this is your tutor AB. Today we're going to be solving a problem from the May 2021 IB chemistry examinations. This is a paper 1A HL question worth 1 mark. Let's get started. In which series are all carbon atoms sp2 hybridized? Now, just for your convenience, I'll give you a list of the hybridization that occurs. Just so you know, the hybridization of an atom depends on the electron domains around it. If an atom has 4 electron domains, it is sp3 hybridized. If it has 3 domains, it is sp2 hybridized. And if it has 2 domains, it is sp hybridized. A domain is counted as either a lone pair or a bond. Doesn't matter the type of bond, a single, triple, double, they're all a single domain. Okay, so they're asking us in which series are all the carbon atoms having sp2 hybridization, meaning having only 3 domains around it. So let's see. Let's just go one by one. Okay, so let me just lasso this to the top. So you refer so it doesn't take up too much space, like that. You can refer right there. So let's go from part A. Okay, let's draw out the molecule for each one of these things. There's of course faster ways to do this, but for the convenience, for your learning, I think this is the best way to understand. Let's draw C2H2 first. So you must have a C, and you have a hydrogen and hydrogen. And of course, a carbon must have 4 bonds to it, right? So this satisfies it. Now, if I look at the hybridization, well, this is definitely not sp3 hybridized because this carbon, each carbon only has an sp hybridization. Each carbon only has 2 domains around it. So immediately, this whole thing cannot be the answer. A just cannot be the answer because all the carbon atoms in this series must be sp2 hybridized, and immediately one of the molecules does not follow this rule, C2H2. So whichever option has C2H2, I can cross out. Now I can look at part B and D. Let's try, for example, let's go for D now, right? C2H6. Let's try drawing C2H6. So C and C, 1, 2, 3, 1, 2, 3, right? Is this not the molecule for C2H6? But if I look at each carbon, they both have 4 domains around it. So in this example, C2H6 has an sp3 hybridization, the carbon in this molecule. So again, this cannot be the answer because all the molecules in the series must satisfy the requirement of sp2 hybridization. But immediately C2H6 doesn't, so I can cross out this whole option. It doesn't matter what if the others are or not. C2H6 doesn't follow it, so D cannot be the answer. And finally, let's check B. If I check B, C2H4, let's try drawing this. C and H4, so 1, 2, 3, 4, H. So it must be double bond there, H. I'm able to determine the double bond, triple bond, just knowing the octet rule and valence electrons, okay? Since carbon has 4 valence electrons, it's able to have a total of 4 bonds to it. So carbon has 4 bonds to achieve the noble gas configuration. So if I look at the carbons, they both have 3 domains. 3 domains being sp2 hybridization. C2H4 works out. Now, what I'll do, I'll move this to a side and let's try another one, right? So I know that this one works. This works. How about H2CO? So let's try how this look. H2. Actually, we immediately know that B must be the answer, but just for your convenience, I will draw it out all. So H2CO, so C, and there is an O. There must be a double bond there, and there. I'm not too worried about the geometry of this molecule, just trying to find out what is the domain around it. Just a simple Lewis formula. So if I look at H2CO, this satisfies again because carbon only has 3 electron domains around it, meaning again sp2 hybridization. And finally, I can check HCOOH. So let's try that out. H cross. Loose formulas are all about trial and error, as you know. O and H, that works, everything is satisfied. Actually no, carbon is not satisfied. Okay, so we have to find out how we can do HCOOH. Okay, let's try it out. So we have a carbon which is going to be bonding with the hydrogen, which will have to be bonding with the oxygen, which, and then double bonding with the oxygen. Okay, double bonding with an oxygen, which is bonding with a single oxygen, which is having a hydrogen. And this is not exactly the right way to draw this, but it does satisfy. And we see here carbon has 3 electron domains around it, so we know that again sp3 hybridization. HCOOH works as well, so B must be the answer. Thank you for watching. If you have any questions, leave it down below. I'll answer it as soon as possible. Thank you for watching.